Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. So today we are going to start a new topic, that is the traveling salesman problem. So traveling salesman problem can be solved with various number of methods, but in this lecture we will limit our study to the heuristic method and we will see how a traveling salesman problem can be solved by heuristic method. So first of all, let us understand what is traveling salesman method. So in traveling salesman method, a salesman has to visit n number of cities and he starts his journey from his home city and he wishes to visit each city once and only once and return to the home city. So as it has written there are a number of cities a salesman must visit. He starts his journey from his home city, passes through each city once and only once and return to his home city. Now traveling salesman problem can be of two types, symmetrical problem or asymmetrical problem. Now if the time, distance or cost does not depend on the direction of travel, then it is called symmetrical matrix. So as we can see in this particular problem, there are 4 cities and the distance, time or cost from one city to another city is same for the return journey. Suppose from 1 to 2 the cost here is 30 and from 2 to 1 the cost here is 40. So there is a difference in the cost while returning to that particular city. So this is asymmetrical type of problem, and if both the costs are same, so then it will be a symmetrical problem. Okay, so let us start solving the problem. The question says that a salesman wants to visit cities 1, 2, 3 and 4. He does not want to visit any city twice before completing the tour of all the cities and wishes to return to his home city, the starting station. The cost of going from one city to another in rupees is given in the table below. Find the least cost route. So in this matrix it has been given that there are 4 cities the salesman want to visit and the cost coefficients are given from one city to another, and one thing here is given as the value of city 1 to 1, 2 to 2, 3 to 3, 4 to 4 is given as 0. Now this value 0 does not mean anything, because if a salesman visit from city 1 to 1, 2 to 2, 3 to 3 or 4 to 4, then it will create a sub tour which we do not want in traveling salesman problem. So what we will do is we will put a penalty there for cell 1, 1, 2, 2, 3, 3 and 4, 4. So we can use the value infinity or the value m, which is a very large positive value. So here this time I am using the value infinity, so I am putting the penalty as infinity here, and these are the cost coefficients 30, 80, 50, 40, 140, 30, 40, 50, 20, 70, 80, 130. So here in this matrix these are the cities 1, 2, 3, 4 from which it is traveling to the city 1, 2, 3 and 4. So here to solve this by heuristic method, we know that we need to assign the cities. What we need to have is zeros in each row and each column. So let us start solving. As we know that it is a square matrix, so we will rightly move on to the step 2 where we need to reduce the matrix. So first we will see row reduction. That means the minimum value in a row is selected and each element of this row is subtracted by the minimum value. So let us start here. These are value infinity. So 30 minus 30 is 0, 80 minus 30 is 50, 50 minus 30 is 20. Similarly in row 2, minimum value is 30, so 40 minus 30 is 10, 140 minus 30 is 110, 30 minus 30 is 0. Here minimum value is 20, so 40 minus 20 is 20, 50 minus 20 is 30, and 20 minus 20 is 0. Here the minimum value is 70, so 70 minus 70 is 0, 80 minus 70 is 10, 130 minus 70 is 16. Now in this we can see that we have zeros in each row, but we do not have 0 in each column. So we need to do column reduction here. For column reduction, we will select the minimum value in the column and subtract each element of that column by that particular minimum value. So column 1 and column 2 are already having a 0, so no change will be there in column 1 and column 2. So this will be 10, 20, 0, 0, 30 and 10, and in column 3 the minimum value here is 50. So 50 minus 50 is 0, 110 minus 50 is 60, and 60 minus 50 is 10. This is 20, 0, 0. Now once we have reduced our matrix, we will try to assign in this matrix. So we will make assignment first row wise, then column wise. If there is a single 0 in the row, we will try to assign that, and if there are more than one 0, we will skip that row and move on to the next row. So let us see, for row 1 we can see that we have more than one 0 here, so we will skip this row and move on to row 2. In row 2 we have a single 0 here, so we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column, so this 0 gets crossed out. Now in row 3 we do not have any assignable 0, so we will skip this and move on to row 4. In row 4 we have a single 0 here, so we will assign this, and now we will move column wise assignment. So column 1 is already assigned, column 2 has a single 0, so we will assign this 0, and once this 0 is assigned, no more assignment can be done in this column and in this row, so this is crossed out. Now as we can see that in a 4 cross 4 matrix we have 3 assignments, that means we do not have an optimal assignment yet. So the next step we'll do is we'll draw the minimum number of line that crosses all the zeros. So for that we will select first take the unassigned row. So this is the unassigned row. If this row has the 0, take the corresponding column. So this is the 0, and if this column has an assignment, take the corresponding row. So, and here we have no more zeros, so no more further ticking is possible. And now we need to draw lines through unticked row and ticked column. So we have drawn line through unticked row and ticked column. Now as we can see that now among the cell where no lines are passing, we will select a value theta, which is the minimum value among these. So among these 10 is the minimum value, so value of theta is 10. Now we need to create the new assignment matrix. For that, the cell where no lines are passing, the new Cij, that is the new cost coefficient, will be equal to the older cost coefficient minus of value theta. So here 10 minus theta is 10 minus 10, that means 0. Infinity minus 10 will remain infinity. 60 minus 10 is 50. This is 20 minus 10 is 10, 30 minus 10 is 20, infinity minus 10 is infinity. And the cell where single line is passing. So for this cell, the older Cij will remain same for the new Cij. So we will write this will be remain infinity, 0, 0, this will be 0, 0, 10, 10 and 0. Now we have cell where two lines are passing. So for this cell, the new Cij will be equal to the older Cij, that is the older cost coefficient, plus the value of theta. So this is 20, 20 plus 10 is 30, 30, and here infinity plus 10 will remain infinity. So we now have the new matrix for assignment, and let us try to assign in this matrix. So we will start from row 1. In row 1 we have more than one zero, so we will skip this row, and moving on to row 2 we again have more than one zero, so we will skip this. Now moving on to row 3 we have a single zero here, so we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. So now this 0 will get crossed out. Now moving on to row 4, we have a single 0 present here. So again we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row or in this column. So this 0 will get crossed out. Now moving on to column assignment. Column 1 is already assigned. Column 2 has a single 0, so we will assign this 0. And once this 0 is assigned, no more assignment can be done in this column and in this row. So this 0 will also get crossed out. Now in this matrix also we have 3 assignments in a 4 cross 4 matrix. This shows that our solution is still not optimal. So again we need to draw a minimum number of lines that will cross all the zeros. For that, now we will select, first take the unassigned row. So this is the unassigned row, and if this row has the 0, take the corresponding column. So it has 2 zeros. Now if this column has an assignment, take the corresponding row. So these are having assignment, take the corresponding row. Now draw lines through unticked row and ticked column. So this is the only unticked row, and these are the ticked column. So we can see that now again we need to select the value of theta, which is the minimum value among the cell where no lines are passing. So we can see that among these cell minimum value is 10. So the value of theta is again equal to 10. Now we need to create the new assignment matrix. For that, the cell where no lines are passing, the new Cij will be equal to the older Cij minus the value of theta. So here we can see that infinity minus 10 will remain as infinity. This will remain infinity. 50 minus 10 is 40. 20 minus 10 is 10. Infinity minus 10 is infinity. 10 minus 10 is 0. 10 minus 10 is 0. Now for the cell having a single line passing through it, the Cij, the new Cij will be same as that of Cij in the previous matrix. So these values will remain same. So this will be 0, 10, 0, 0, 0, 0, 0 and infinity. Now we have the cell where 2 lines are passing. So as we can see that for this, the new Cij will be equal to the older Cij plus the value of theta. Okay, so older Cij is 30, 30 plus theta, that means 30 plus 10 is 40. And similarly here infinity plus 10 is remain infinity. Now we again need to assign in this particular matrix. So we will try to assign here. We will start from row 1. In row 1 we have more than one zero, so we will skip this. In row 2 we have more than one zero, so we will skip this. In row 3 we have a single 0 here, so we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column, so this 0 gets crossed out. Now moving on to row 4, we have more than one zero, so we will skip this and we'll move on to column. So column 1 has more than one zero, so we will skip this. Column 2 has more than one zero, so we will skip this. Column 3 has more than one zero, so we will skip this. But as we can see that now we still have the number of zeros, and because one zero has been crossed out in this row, there is a single assignable 0 present. So again we will try to assign first row wise. So we can see that row 1 has more than one zero, so we will skip this. Now row 2 has a single assignable 0 here, so we can assign this 0 now. So once this is assigned, no more assignment can be done here and no more assignment can be done in this column, so this 0 gets crossed out. Now moving on to row 3 is assigned. Moving on to row 4, there are more than 1 0, so we will skip this. Now again, if we move column wise, column 1 is assigned, column 2 has more than 1 0, column 3 has more than 1 0. So as we can see now that we could not able to assign because there are 4 zeros, and in each row there are more than 1 0, and in each column there are more than 1 0 for assignment. So what we will do, we will again select any one of them arbitrarily and select the corresponding assignment. Now let us see, if I assign this cell, that means no more assignment can be done in this particular column and in this particular row, so these 2 0 will get crossed out. Now as we move column wise, row wise, we can see that in the row 4 we have now a single 0, that means this 0 can be assigned. So as per assignment problem, we can see that in a 4 cross 4 matrix we have 4 number of assignment. That means our this solution is optimal. So this solution is optimal according to the assignment problem, but we are solving a traveling salesman problem, so we need to verify whether this optimal solution satisfy the traveling salesman condition or not. So let us see here. We can see that starting from city 1, from city 1 it moves to city 2. So this is 1 2 3 4, 1 2 3 and 4. So salesman starts from city 1 and goes to city 2. Okay, now it starts from city 2 and goes to city 1. So as we can see here that it is coming back to the same city 1 before completing the tour. And if we see further, if it leaves from 3, it goes to 4, so 3 to 4, and from 4 it again comes back to 3. So we can see here that these two are sub tours, and this condition does not satisfy our traveling salesman problem. So what we will do is, we will not select this particular cell arbitrarily, and we will select some other cell so that we may get our optimal solution, or we may satisfy the traveling salesman condition. So as per this particular matrix, these are the two sub tours which is making this problem not an optimal problem. So let us erase this, and I am writing the same matrix here, that is the value of infinity, 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 infinity here. This is 0 0 40, this is 0 40 0 10 10 0, this is 0 0 and 0. So as we can see that we have already make assignment. So till here we have already made assignments. So this was assigned, and we have the situation where we are not able to assign between these 4 zeros, and we have seen that if we have selected arbitrarily this cell, we are not satisfying the traveling salesman problem. So let us now this time select this particular cell, and if we select this cell, that means no assignment can be made, no more assignment can be made in this row and in this column. So these 2 zeros get crossed out, and there is only a single assignable 0 present in row 4. That means this 0 is now assigned, and now again we are having 4 assignments in a 4 cross 4 matrix. So this is also an optimal solution according to the assignment problem, but we need to check whether it is satisfying our traveling salesman problem or not. So let us understand this. Again we have 1, 2, 3, 4 cities, 1, 2, 3 and 4. So we can see that from 1 it goes to 3, from 1 it goes to 3, and from 3 it goes to 4, from 3 it goes to 4, from 4 it goes to 2, from 4 it goes to 2, and from 2 it goes to 1. So we can see that now for this particular solution it is satisfying the traveling salesman problem, as that salesman is visiting each city once and only once, and it is returning back to its home city where it has started. So this is the optimal assignment for this traveling salesman problem. And now we need to calculate the minimum cost. So the Z minimum for this particular value is 80. This is 80 plus 40, 80 plus 40 plus 20 plus 80 plus, okay, this is 80. So we can see that this is coming as 220 rupees. This is in rupees. So we can see that to solve the traveling salesman problem we need to satisfy certain conditions, which is that the salesman must visit each city once and only once, and it should come back to the original city or the starting city where it has started. So I hope this topic is clear now, and if you like the lecture, please share the lecture. Have a nice day. Thank you.